Hello and welcome to the Fox Technologies webinar on SSH security. My name is Mark Lambiazzi. I'm the CTO of Fox Technologies, and we appreciate you taking the time to join us today. A little housekeeping first. All attendees are on mute during the webinar, but we value your questions, and we'd like to invite you to submit them through the GoToMeeting control panel, and we will follow up and answer all of these questions that we get in our blog tomorrow. I'd also like to let you know that this is part of a three-part series. Today, I'm going to be talking to a presentation that was originally titled, "Is SSH really secure? Probably not the way you're doing it." And we are going to have two more webinars following on, addressing many of the issues that are going to come up today and demonstrating how our product, Fox Server Control, addresses and mitigates many of the risks associated with SSH deployments. So, SSH. SSH has been around for a very long time. Some of you may have been using SSH for 20 years or more. So why are we talking about it today? It hasn't received the kind of press and notoriety as OpenSSL recently. We don't know of any glaring holes in the protocol or implementation itself. And yet SSH has received a lot of visibility. And many of the IT staff that we talk to have been in conversations where their management has been bringing up SSH and asking sometimes hard questions about the security of the deployment at their enterprises. Well, a number of things in the course of the last 2 years have happened that have driven this awareness. First of all, there are a couple of reports that were written on SSH security, one by Ponemon Institute and another by Forrester. And they had some very scary numbers associated with SSH in these reports. Big numbers, like nearly 50% of respondents have reported they've addressed security incidents related to SSH. And numbers like 75% of enterprises polled didn't have any controls around their SSH deployments. And more recently, US NIST has published guidance on automatic authentication in SSH. So there's been a lot of talk about SSH, and there's been a lot of research into how it's being used and where its weaknesses are. And as the title said, SSH can be secure, but with these numbers, the high percentage of companies that are reporting that they're having issues with SSH, it could be a very good chance that your deployment may fall prey to some of these common problems and how it's deployed. So let's take a look at SSH itself. Now, SSH is a standalone package in most cases, and we drop it onto our servers, and it's driven by its underlying configuration file. And we have a number of options when we set up SSH for how we can control it. Inside our configs, we can go in and we can turn on and off different features, whether we allow something like host-based authentication or public key authentication. We can turn off root login, or we could allow it. We can allow or deny users and groups of users. And those are things that really address some of the access control features that are available in an out-of-the-box SSH deployment. There's some other things that we can configure in there that have to do with the security of the implementation itself. Is the SSH daemon running? Are we using privilege separation? Have we configured rooted directories? Now these are some of the fundamental things that drive how the service operates, and a lot of the security of that service itself are derived from some of these choices that we get to make, and whether we allow protocol 1 or 2 or both, and that rides down to the protocol security. And everybody should, unless they have a very good reason, be limiting their SSH usage to protocol 2 these days. There's enough information that 1 is weak enough or weakening enough that it's really no longer adequate to protect us. And then there's some other things that we can do with the service itself, such as enabling our logging and to what degree we get messages about who's connecting and what's going on with our service. Logging is absolutely essential to the security posture of an enterprise. If we can't see it, if we have no visibility, then when bad things happen, we can't go backward in time and find them if we don't have some record. But it also gives us the opportunity to use that information to generate alerts and to find bad behavior as close to when it's happening as possible. And to a small degree, SSH gives us some control over what people can do once they arrive at the service. And within these local options, one of the few things we can do is we can turn on or off tunneling or forwarding, which is a neat trick and lets us use SSH maybe to pull a graphical user interface back to our client system, or use it VPN-like to pass traffic through to the host we're connecting to, or even into the network that host is on. So what is it that local options can really control? Well, local options, if we look at the allow users and groups, we're talking about the who can log in. And if we look at some of the controls, like whether password authentication is enabled or public key host-based, we're talking about how they can log in. And if we look at options like tunneling, and maybe some of the other things that can be controlled, we're talking about what they can do. So the who and the how and some of the what are things that we can do in SSH at a local level in the configuration to control our service and how it can be used. Well, let's start with who. First of all, who is who? In the local configuration, there are limitations to what we can do to control who. We can allow or we can deny. And if we have a large server deployment and a large number of users, managing those lists across that deployment can be quite a burden and possibly quite error-prone. We can also allow or deny based on groups, which is good. We don't have to manage at the individual level quite the same way. Still a lot of work in the local configuration. But back to my question, who is who? We can allow or deny who, but who is not just people. For SSH, there are different kinds of accounts. Who to SSH is really not about a person, it's about an account. And SSH is not just used by people. SSH can be used, of course, by people, but also there are system accounts that may leverage SSH, and there are functional accounts. These functional accounts, or service accounts, or application accounts, they can go by a number of names. The entire NIST guidance really wraps itself around this one class of account, and actually, beyond just this one class of account, one use case, which is automatic authentication. When we have an application on one server or host that needs to be able to send commands or retrieve data from another, it's not interactive. There's not a person sitting at the keyboard typing in a password. It has to be able to occur automatically. So who is who? We have people, we have system accounts, we have functional accounts. And with our local configurations, we can really only choose to allow or deny based on their account name. Now the how is how these accounts can authenticate. And there are a number of choices that we can make in our local configurations for SSH about how people can authenticate. We can allow password authentication or user keys, and SSH keys have taken on a life of their own in security discussions. Most of the content of the papers I've talked about, the reports that have been out in the last 2 years, they're really very tightly focused on user keys and some of the problems that come up. And the NIST document is almost entirely focused on these functional accounts, this automatic authentication, and automatic authentication leveraging user keys. There's some other things that we can do. There are SSH certs, similar to a user key, but the integrity method is based more like an SSL certificate. We can plug in third-party authentication through the pluggable authentication model. There is also a host-based model. Now, host-based is actually a very interesting and little used SSH authentication method today, often considered very insecure, and yet its primary purpose in the past was to solve that automatic authentication problem. Well, out of the box, host-based authentication certainly leaves a lot to be desired for its security model. However, if you join us for some follow-on webinars where we talk more specifically about box server control and how it solves problems, you'll see that we've enhanced host-based authentication to provide that automatic authentication for those functional accounts in a way and to a degree that competes with SSH user keys in the security model and is actually much easier to administer and maintain. Kerberos has become a very popular authentication method for SSH lately. This is driven by the same kinds of initiatives to reduce the number of places we have to manage accounts and passwords in our enterprise. And centralizing management of accounts and passwords or authentication can provide a great value to an enterprise, especially with many servers and a number of people. Reducing the overhead of managing host by host certainly adds value by reducing administrative overhead and maintaining that domain of Unix and Linux servers. There's the generic security services API also, which again, not that often used, but it's another way that we can plug in a third-party authentication module into our SSH service. So a number of different ways that we can enforce for how. And these can be turned on and off in our local configuration. One of the problems with local configurations, though, is that once we turn on or off any of the settings, they become globally available to any of the accounts that we may have logging in to that server. So the problem with public keys. I mentioned that a lot of the visibility that has been drawn to SSH lately has been based on these reports about insecurity at really grandiose scales. 50% of enterprises have suffered a breach. 75% aren't managing their SSH correctly. These are really big and scary numbers. And if you believe the report to be credible, and there's no reason not to with these reports, I'm sure they've done their research, then a manager looking at this is going to wonder if they're inside the 3 out of 4 who aren't doing this right. Key rotation is a big problem with public keys. Again, once we turn public keys on, they're on for everybody that can access that box. It's not a very granular setting. All of the settings in the local config file are really sledgehammers to the service. It's all or none. So we have to manage these keys somehow if people are going to use them. And managing the keys is, yes, being able to rotate them, possibly. We rotate our passwords. We've all finally gotten into the mindset that passwords need to be changed about every 90 days. less for more critical systems. And for many years, the burden of that, the burden on the end user, the burden on support, the burden on administration for implementing password rotation was considered greater cost than the risk or the threat warranted. Well, today, with all of the many breaches, many based on stolen credentials, it seems that most enterprises, most managers in IT, most security managers, and people within the different business units that are the customers of IT have recognized that these are now essential practices to the security of our organizations. So with keys, well, like I said, it's all or none. So all somebody has to do is be able to add a key to a server, possibly if it's configured that way, and they can start using keys. And those keys may or may not ever get rotated. So a big first step for keys is, well, does your enterprise really need to use them? Do you need to use them for some purposes, but you may not want to use them everywhere? And you have to describe that in a policy. It's really essential as a starting place to define the goal and the rules around your environment. And again, because it's all locally configured within our SSH configuration, locally configured with keys on that local server host, well, there are some things that we can do in the SSH configuration to prevent an end user from adding their own key. But, well, what about administrators? These are our most trusted individuals, and they have all power over the machines. If they decide that it would, say, enhance their productivity, be easier, simpler for them to be able to use keys to do their job, the policy itself won't stop them. So can the admins add keys? And that one's a very difficult one to stop, and words won't necessarily do that. So public keys have become a well-known issue. And one of the reasons that public keys have been adopted so broadly is there's a lot of advice out there, well, that passwords are just no good anymore. And Kerberos is better than passwords, but SSH keys are better than all of that, and that's what you should use. But although it may be a better authentication mechanism, it brings with it a whole bunch of other issues that really must be addressed by the enterprise to adequately secure their adoption of keys as an authentication method. Now, I mentioned that SSH also has some control over the what. Now, tunneling versus no tunneling. This may not seem like a topic that warrants so much discussion, and really, tunneling versus no tunneling. Tunneling is a nice feature. It can give the end user a certain experience. But once again, this is one of those things that we either turn it on or turn it off. And the thing that I have a problem with in tunneling is the advice that I see when I look around the internet for information on how to configure SSH. There are a number of places out there that in the guide on how to set up your SSH, it says, well, you could turn it off, but really why bother? Because the user that logs in can just set up some other process to run their own tunnels. So it really doesn't give you much security to turn it off. Well, I would agree with that. I would agree that turning off tunneling, somebody could go in and bypass my settings, but then they have to do something. It's like banner messages. A banner message, if an attacker is trying to log into your host, they're going to laugh at that. It's not going to stop them. But in many jurisdictions, if you don't have some authorization message up front, you lose the standing to act after bad behavior. turning tunneling on or off, it needs to be a conscious decision. But one of the things, turning it off doesn't necessarily improve the security of your host by a whole lot, but it improves the security posture of the enterprise by a bunch. If people are actively bypassing or setting up their own services, it was an expressed action. It's not that they just used something that you left there and, well, I thought I could use it because it was there. And with tunneling, does everybody really need tunneling? Again, it goes back to our local configurations, and it's all or none. Now, there's other things that we can do with SSH too. There's, of course, the shell. And SSH is, on the people side of things, most often used to get a shell, to administer the server, to administer a database or an application. It tends to be used by the more skilled and more trusted people within an enterprise who are in there tinkering around with the mission-critical applications and services and servers that our enterprises rely on. But does that functional account that is passing data, well, maybe it could get by with only SCP, with a secure copy protocol moving data back and forth. Or maybe that application does need a shell, and it's running scripts on some remote server to perform some action. But again, we don't have a lot of control with the native underlying mechanisms that we have available in SSH. So access control. The local options give us some control over who and how and what. But when we talk about who, what are we really talking about? We're talking about accounts. We're not talking about people. For all we know, somebody's cat is sitting at the keyboard poking away. It's really their account. And when we consider our accounts, we need to consider the difference between user accounts and system accounts, user accounts versus those functional accounts used by services or applications, and local accounts versus centralized identities. Each of these adds value in existing. Each of them presents their own management challenge. Some have inherent value. Some you simply can't do without. Every Unix and Linux system has at least one system account, root. You cannot get away from it. And by the way, root, if we centralize our people accounts, it's difficult in many central identity structures to manage that local account that absolutely has to exist, or that absolutely critical functional account, the Oracle account that runs the Oracle process for the database on that server, or the MySQL user, or the Apache user. These are all things that need to be considered when we're talking about SSH and access control. And access control is really about the accounts, and we have to manage those. Now, centralized authentication. Centralized authentication offers a lot of benefits. One of the benefits is that if all of our authentications are going through a single place, we have a consolidated log stream, a consolidated audit trail for access through SSH, or really through any method that people are authenticating. There's a lot of value to that. And beyond that, there's a greater value in the ability to reduce account management overhead. If you had 10 users, 100 systems, and you had to add 10 accounts to 100 systems, well, that's a burden, and you'd get it done, and you might lose a day or two of work with people sitting around waiting for accounts to be created. But disabling those accounts, deprovisioning them, well, one disgruntled employee who's not deprovisioned on time can cause an awful lot of mischief. And in the news recently, the lead security architect at Home Depot got himself in a lot of trouble at a previous employer based on going back in to systems, or actually he went into the systems before he was terminated, but we have many tales of people that are doing it afterwards when their account should have been deactivated. And what about integrity? All of these local configuration files, the server has to defend those. Okay, that's fine if I'm going in and I'm a regular user and I can't really go and manipulate any of these system files. But what about those privileged users? A lot of the time SSH, it's being used by our administrators, people who know how computers work, are typically quite skilled, and we're giving them often complete control over these servers. They can simply do whatever they want. It's entirely based on trust that they are not going to go in and make changes unless we have some way of also managing the level of privilege, what our most powerful administrators can do once they get to a system. Does every administrator really need to be able to manipulate the SSH configuration? Or do our sysadmins really have boundaries with what they should be doing to accomplish their duties? And can creating boundaries help defend our systems by maintaining or defending the integrity of our configurations? These are all very important topics. And today I've had the opportunity to touch on some of the challenges with an out-of-the-box SSH deployment. Deploying and managing SSH on a server-by-server basis is really quite a challenge. Addressing the security for your enterprise, well, it's an oft-repeated refrain from security professionals, but your security implementation should start with a well-defined security policy. Somebody, probably the security group, should be in charge at least of the rules around how SSH should be implemented and the permissions and rules around its use. And likely that they would be in charge of the implementation, but they should at least be consulted or a part of it or aware of how it's being done. And in addressing the security of SSH, all three of these areas that I've touched on today, access control, account management, privilege enforcement, all three of these should be included in your evaluation of the security you have in your SSH deployment and in establishing the policy that you want to implement for the security of your enterprise. The three are tied very tightly together. In future webinars, we're going to have the opportunity to address these different risks and show how box server control can be applied to mitigate the access control problem by dealing with the who, where, when, how, and how of SSH access. And I'll explain who, where, when, how, and how next week. And in our third and final webinar of this series, we're going to show how privilege enforcement is a very valuable tool and how being tightly integrated with SSH and with the management, tying all three, the account, the access, and privilege together, makes for a more tightly bound security tool to implement your policy and mitigate your risk. We certainly appreciate your time. We'd like to remind you that if you have any questions, you can submit them and we will address those on our blog tomorrow. Really good questions we might bring into our next webinar and answer them next week. We certainly appreciate your time and attention, and we look forward to talking to you soon.